Good evening to everyone. In this lecture, I would like to discuss the concept clustering from the course Introduction to Machine Learning. So these are the contents I would like to cover. The first one is what is cluster analysis, applications of clustering, what is good clustering, partitioning clustering, hierarchical methods, and summary. First is what is cluster analysis. So first we can see what is the cluster. A cluster means a group of objects that are similar. Clear? It means similar objects can be maintained as a one group that is called as a one clusters. Okay, and the dissimilar objects are maintained in another clusters. Okay, that means the cluster is comes into unsupervised classification. Okay, that means supervised and unsupervised learning is there. So in the unsupervised classification, the clustering is coming. Like we can call it as a unsupervised classification means there is no predefined classes for clustering. That's why it's called as a unsupervised classes. Okay, so let's see one example. The cluster analysis. Let's take as these are the different types of clusters. These are some of the points in cluster 1. These are some of the points in cluster 2. These are some of the points in cluster 3. Okay, that means these are all objects. What are the objects we have to place in cluster 1 are similar. What are the objects are placed in cluster C2 are similar. Okay, likewise we have to form 3 different clusters. And what is the condition for good cluster says we have to maintaining the intra-cluster and inter-cluster. The intra-cluster means the distance between two objects within the cluster is called as the intra-cluster. Inter-cluster means the distance between two objects. There is one object from cluster 1 and another object from cluster C. This is called as inter-cluster. And if you can take two objects, any two objects in particular cluster is called as the intra-cluster. Okay, so the good clusters is formed with high inter-cluster similarity and low intra-cluster similarity. Okay, that is called as the good cluster. Okay, so these are some of the applications of a clustering. So mainly the clusterings are used in pattern recognition, spatial data analysis, image processing, economic science, World Wide Web. That is called as WWW. And what are some of the examples of clusters or land use? For example, identification of areas of similar land use in a Earth observation database. So that means in the entire Earth, identifying what are the similar lands we are having. So those similar lands we have to group as like insurance. Identifying group of motor insurance policy holders with high average claim cost. Okay, so how many members are having with motor insurance policy? All those are maintained as a one group. That's called as one cluster. City planning. Identifying the groups of house according to the house type, value, geographic location. So based upon house type, value, geographic location, we have to identify the groups. That is called as one example of clustering. And this is what is good clustering. The good cluster must having the high intra-class similarity and low inter-class similarity. I already discussed. Okay, this is one cluster. This is the one cluster. This is the one cluster. These are the objects of cluster 1, objects of cluster 2, objects of cluster 3. This is called as intra-cluster. Intra-cluster. The distance between this object is called as inter-cluster. Okay, so now if low inter-cluster similarity and high intra-class similarity, that is the good quality of clusters. And the quality of clusters results depend upon what are the similarity measure we are using. Okay, that is we are having different similarity measures. Those are called as equivalent distance, Manhattan distance. Okay, likewise we have different dissimilarity distance metric formulas. Okay, so based upon similarity formulas, we have to finding different types of clusters. The quality of the clustering method is also measured by able to discover some or all of the hidden patterns also. And these are the major clustering approaches. This is called a partition clustering algorithm. That means in partition clustering algorithm, initially we have to divide the given dataset into some number of the partitions. Based upon the number of partitions, again we have to form the clusters based upon some criteria. Okay, that is partition algorithm. Hierarchical algorithm means in this we are using the tree structure, or we are following called some dendrograms. Based upon some as like tree structures. Okay, so we have to form the clusters. In partition algorithm, initially we have to define the number of clusters. Whereas in hierarchical clustering algorithm, we cannot define the number of clusters. Okay, so at any time we may stop to partition the clusters. Okay, and density based clustering based on the connectivity and density functions. Examples for partition algorithm is just k-means algorithm and k-meroid algorithm. Those are some of the examples of partitioning algorithm. Hierarchy algorithms are what is called as agglomerate hierarchy clustering algorithms, divisive hierarchy clustering algorithms, the top-down and bottom-up approach by using different linkage techniques. Those are called as single link, min link, max link. The density-based clustering algorithm example is DBSCAN. DBSCAN. So apart from these three clustering approaches, we're also having some more clustering approaches such as grid-based clustering algorithms and model-based clustering algorithms. But in this section, I would like to cover partitioning algorithm and hierarchical algorithms. In partition algorithm, I would like to discuss k-means clustering algorithm. This is the algorithm for forming the clusters using the k-means. So in this, we are in the 4 clusters. What you have to do is partition objects into k non-empty subsets. Let's take as we are having the 10 objects. 1, 2, 3, 4, 4, 5, 6, up to 10 objects or 10 points. What you have to do is, for example, if you can take as some k equal to 3. That means initially we have to divide these 10 objects into 3 different groups. That assuming is cluster 1, cluster 2, cluster 3. In cluster 1 I have to maintain in object 1, 2, 3. In cluster 2 I have maintained some 4, 5, 6. In cluster 3 I can maintain 7, 8, 9, 10. That is first step. Partitioning objects into k non-empty subsets. What is the value of k here? 3. That's why k non-empty subsets. And compute the seed point as a centroid. So that means we have to find out the centroid to each and every cluster points. To each and every cluster points. So in cluster 1 we have common objects, 3 objects. With these 3 objects we have to calculate the centroid. As like with cluster 2 we have to find out the centroid. From cluster 3 we have to calculate the centroid. Okay, the centroid is center of the cluster. Let us assume, for example, the cluster C1 contains 3 points, for example 1, 2, some 2, 3 and 4, 5. We have common objects, 3 objects in cluster 1. First object is 1, 2, second object is 2, 3, third object is 4, 5. The center you have to calculate as 1 plus 2 plus 4 by 3. And the second center is 2 plus 3 plus 5 by 3. That is 7 by 3, or 5 plus 5, 10 by 3. This is the centroid. Because you have to calculate the centroid, okay, to each and every cluster points. And assigning each object to the cluster with the nearest seed point. Okay, this assigning each object to the cluster with nearest point is based upon some of the distance method. Okay, and the go to step 2, stop when no more new assignment is applied. No more new assignment is occurred. Until then, we have to go to step 2. Okay, this is the algorithm for k-means clustering algorithm. Okay, so let's see this example taken as 3 clusters. Okay, C1, C2, C3, C4, 3 clusters. Okay, so each and every initially we have to partition objects into k non-empty subsets. Okay, so C1 is these points, C2 are these 3 points, C3 are these 3 points. Okay, so now see this, we have to again calculate the centroid for C1, the centroid for C2, and the centroid for C3. Clear? So now what you have to do is we know that 3 centroids. We're getting one center for C1, one center for C2, one centroid for C3. And again we get, that means we're getting how many centroids? 3 centroids. Okay. So now what you have to do is from these 3 centroids, let's take as first object. We have to calculate in the distance from object 1 to centroid 1, distance from object 1 to centroid 2, distance from object 1 to centroid 3. We are calculating distances from 1 to centroid 1, 1 to centroid 2, 1 to centroid 3. So out of these 3 values, which value is having? For example, distance 1 to centroid 2 is minimum. Then we have to assign this cluster 1 into which one? Object 1 into which one? Cluster 2. Okay. So likewise, you have to repeat that process until no more new assignment is occurred. Okay. So here one way is we may assigning some points to each and every cluster, or out of 10 objects, I can take now 3 centroids. Maybe the first object is centroid for cluster 1. For example, the fourth object is centroid for cluster 2. Maybe some seventh object is centroid for cluster 3. So by this assumption also we may forming the Clemens clustering algorithm. Okay, that means the centroid one for cluster 1 is object 1, the centroid 2 for cluster 2 is object 4, the centroid for cluster 3 is object 7. Again we have to repeat the what's called as step 3. Okay, so that means go back to step 2, stop when no more assignment. Okay, this is some of the K-means clustering method. Okay, just what you have to do is fix seeds. That means fix the centroids, 2 centroids. Okay, this is the one cluster, this is the another cluster. What you have to do is reassigning clusters and compute centroids and reassign clusters. So reassign, for example, in these points, this is the one seed or centroid, this is the another seed. What we is again we have to reassign clusters means from the seed we have to calculate distance from this point and from the center this point. Okay, that is this is the one seed, this is the another seed. But assuming as if you want to calculating what is the which take this point will comes into this seed or this seed, that can be calculated by distance from this seed to this point and this point to this seed. For example, the distance between these two is, for example, some 2, let us assume. The distance between this C to some is some 3. This one is minimum. That's why this point, this object may be moving to these clusters. Okay, that means you can reassign the clusters and compute the centers. Maybe after calculating the distance measures, maybe some points comes to this cluster or some points comes to this cluster. From those points, again we have to calculate the clusters, centroids, and again reassign the clusters. Okay. Now this is called hierarchical clustering. The main drawback of K-means clustering is in this K-means clustering we don't know, because initially we have to specify the value of k. If the value of k equal 3 means it forms 3 clusters. If the value of k equal 4 is it forms 4 clusters. Okay. So initially we have to define the value of k and identifying the best initial centroids is also a more difficult task. Okay, so likewise we are having some difficulties while clustering. To overcome all those problems, we are using the hierarchical clustering. Okay, so what can produce? A set of nested clusters organized as hierarchical tree, and that can be visualized as a dendrogram. This is a dendrogram. A tree like diagram that records the sequence of mergers or splits. Just like as we're having 1, 2, 3, 4, 5, 6, 6 points. Okay, so hierarchical clustering may be agglomerate hierarchical clustering or divisive hierarchical clustering. In agglomerate hierarchical clustering, what we have to do is each and every point can be taken as an individual point. Okay, so from those individual points, we can try to match the nearest points. We can match the points which are having the minimum distance. Clear? Maybe these are the first we have to match 1 3, then we have to match 2 5, then we have to match 4 6. Then we have to match 2 5 with 4. Then we have to match this cluster with this one. Then we have to match this entire one with this one. That is the actual cluster form. First we have to match 2 5. First one is 1 3, then 2 5, then 2 5 with 4. Then these are one cluster, these are single cluster. This type of clustering is called as agglomerative hierarchical clustering. In this, what I have to do is present as each and 5 points. 1, 2, 3, 4, 5 points. So each and every point, take an individual point as an individual cluster. Now we have to find the similarities between all these points. Which 2 points have the less distance, those points can be merged. For example, 1, 2, neither. 3, 4 is neither. The one is similar. 5. Okay, like then we will combine this one. Then we will combine this one. One single cluster. That is called as a agglomerate hierarchical clustering. Okay, so the strength of hierarchical clustering is no assumption on the number of clusters. Okay, so we must stop the number of clusters at any point. For example, if k equal to 2, or k equal to 3, or k equal to 1, at any point we may, there is no assumption for number of the clusters. The two types of clusters, one thing is called agglomerative clustering and diffusive hierarchical clustering. In agglomerative starts with points as individual clusters. At each step, match the closest pair of clusters until only one cluster is left. And diffusive means that is bottom to up. Starts with one cluster. Okay, then you can try to split into some number of clusters. Again, split some number of clusters. Number of that's called as the diffusive can use a top-down approach. Whereas agglomerative can use bottom-up approach. It can follow bottom-up approach. Traditional hierarchy cluster usually similarity dissimilarity matrix. Okay, let's see the example also. Okay, the complexity of hierarchy clustering is distance matrix is used for deciding which cluster to merge or split. At least quadratic in the number of data points, not usable for the large data sets. This is the algorithm for agglomerative hierarchical clustering. Most popular hierarchy clustering technique this one is. Okay, so compute distance matrix between the data points. Okay, first we have to calculate distance matrix. Let each data point taken as a one single cluster, merge two closest clusters, update the distance matrix until only one single cluster remains. Okay, this is single algorithm for hierarchy clustering. We can discuss in this algorithm example also. So, distance between two clusters, how can we measure? Okay, that means for example, taking 5 points, that means 5 clusters. How can we measure the distance between these different types of clusters? For that, we are having different distance techniques, that is called single link distance, complete link distance, okay, and average link, centroid link, okay. Likewise, Watt's distance. Likewise, there are different distance metrics, distance techniques. Okay, single link distance means single link distance between cluster C1 and Ci and Cj is the minimum distance between any objects in Ci and any objects in Cj. That means Ci is one cluster with some set of objects. Here Cj is some set of objects with Cj. The distance is defined by the two most similar objects. That is called as minimum T of x comma y. X belongs to one cluster, the y belongs to another cluster. That is called single link clusters. Let's have an example. This is one cluster. This is another cluster. This is cluster Ci. This is cluster Cj. These are points in C1, Cj. So, minimum distance between any object from cluster Ci and any object from cluster Cj is called a single linkage. That means let's say this is the one object, this is the one object. That means these may be the single. These 2 points will be having the minimum distance between one object from this cluster and another object from this cluster. That is called as a single link. Okay, and Complete link means these are some of the nested clusters format and dendrogram from single link clusters. Okay, let's discuss with an example. Complete link, the opposite. Maximum distance. This is the one cluster, this is another cluster, this is the cluster Ci, this is the cluster Cj. So these are the points of cluster C0, Ci, points of Cj. The maximum distance, any point from any object from cluster Ci, any object from cluster Cj. This is called as which one? Max link or complete link. The minimum distance we can take as which one? Min link or single link. Min link or single link. It is max d of x comma y. X belongs to one cluster, y belongs to another cluster. It's called as the complete link distance. Okay. And group average between cluster Ci and cluster Cj is average distance between any objects in Ci and any objects in Cj. That is d average of Ci comma Cj equals to 1 by Ci into Cj sigma distance of x comma y. That means we can also calculating the average group average distance means, okay, the group average likewise. This is the cluster Ci, this is the cluster Cj. Okay, so Ci in Cj. That means number of points in Cj, for example, 1, 2, 3, 4, 5 into number of points, for example, 1, 2, 3, 4, and 5. Sigma x comma Ci, y comma Cj. Take as any one point from Ci to all the points in Cj plus one point from Ci from all the points from Cj. Likewise, you have to find out the group average distance. This is average link. Okay. Simply what you have to do is in group average is like this. Like this. That is a group or average link clustering. Okay. This is some distance. Okay. And this is centroid distance. Okay. So centroid of di comma dz equals d of ra comma rj. Between clusters Ci and Cj is distance between the centroid of Ri of Ci and centroid Rj of Cj. That means this is the Ci and this is the Cj. These are the points of Ci. These are the points of Cj. We have to calculate the centroid of Ci. Let's take some Ri. We have to calculate the centroid of these objects taken as some Rj. Okay, so the distance between Ri and Rj is a d-centroid. Is a d-centroid. Okay, so what's distance? What's distance? This is the formula we have to follow for what's distance. Okay, this is some of the what's distance for clusters. Okay, single link. Okay, max link, words, and also group average. Let's see. Okay. Like we can form some clusters. Okay. Now here I can discussing an example. Okay. For single linkage clusters. Okay. So this is the example for which one single linkage clustering technique. So this is example for which one Let's find the clusters using single link technique. Use equivalent distance and draw diagrams. Let's take draw the dendrogram. Let's take as we have 6 points. Okay. So how to form the clusters by using these 6 points using the single link. Using the single link. Single link is also called as the middle link. That's called the closest pair between two objects. One object from one cluster, another object from another cluster. This is the initial. So this is initial given input, and these are the points we are having. You can plot those points in the xy axis. See what we have to do is we have to calculate the distance. Here I can increment distance. Calculate distance between P1 to P2, P1 to P3, P1 to P4, P1 to P5, P1 to P6. Likewise, first we are calculating P1 to P2, okay, P1 to P3, P1 to P4, and so on P1 to P6. Likewise also P2 to P3, P2 to P4, P2 to P5, P2 to P6. Likewise again P3 to P4, again P3 to P5, P3 to P3 to P6, and P4 to P5, P4 to P6. Likewise, we have to find out distance between 2 points using the Euclidean distance. Using Euclidean distance, this is the formula for Euclidean distance. X comma y, a comma b are 2 points. The distance between those 2 points is x minus a whole square plus y minus b whole square square root. If you want to calculate distance between P1 to P2, we have to use the formula and then calculate distance 0.23. Likewise, we have to calculate distance among all between every pair of points. Now we get the this is called distance matrix. Distance matrix. So now in single link case, we have to identify what is the minimum value. Let's see. So these are the lower triangle values, upper triangle values. So both are same. Let's say measure our lower triangle value. The minimum value from all these points is 0.11. Okay, that's why first we have to group P3 and P6. Why? Because the distance between P3 and P6 is small than compared to distance between any 2 points. That's why we have to first group P3 and P6. P3 and P6. That is P3 and P6. That's mean the dendrogram can form first P3 and P6. Now what you do is, so initially we are having how many points? P1, P2, P3, P4, P5, P6. Again P1, P2 and so on up to P6. Now already from these 6 points we have to match P3 and P6. That's why the new points now are P1, P2, P3, P6 is now one cluster, P4, P5. And again P1, P2, P3, P6 is one cluster, P4, P5. Again we have to calculate distance matrix. Calculate distance matrix. Clear? Now we have to match P3, P6. Now we have to calculate the distance between P3, P6 to P1, P3, P6 to P2, P3, P6 to P4, P3, P6 to P5. How can calculate? Like this. If you want to calculate minimum distance between P3, P6 to P1, the distance between P3 to P1, the distance between P6 to P1. The distance between P3 and P6 is 0.22, the distance between P6 to P1 is 0.23. So minimum is 0.22. So actually here we are using different linkage or different distance techniques. In min link, here we can use the min. Whereas in max link, here I can use the which one? Max or complete link. Whereas in average, we can using the average of these points or centroid. We can take a centroid of this one, centroid of this one. Yes, centroid distance. Likewise, the different the distance techniques is applied here only. Okay, so here I am using min length. That's why min of distance P3 distance from P3 P1 comma P6 P1. That is minimum of P3 minimum of P3 P1 minimum of P3 P1 comma P6 P1. That is 0.22 come 0.23, minimum is 0.22. As like distance between P3 P6 to P2, that is P3 P2 P6 P2. The minimum is 0.15. So likewise we have to update the distance matrix. So in this, these are only changed. The remaining values are having the from initial distance matrix. Now from these, after these updated values, now what is the minimum value we are having? Let's see, 0.14 is minimum value. Now we have to combine P2, P5. Combine P2, P5. Previously P3, P6. Now how many trusts we are having? 1, 2, 5, 3, 6, 4. Again 1, 2, 5, 3, 6, 4. Again we have to calculate the update the again distance matrix. Likewise. So P3, P5 to P1. Okay, so P2 to P1, P5 to P1, minimum is 0.2 to 0.15. Like we are updating. Okay, that means this is the distance matrix. We form like this. If you want to calculate minimum distance between P2, P5 to P1, how are we calculating? Distance of okay P2, P1, comma distance of P5, P1 from this minimum, that is 0.23. Clear. Likewise, for example, P3, P6 to P1. How to calculating? Minimum of distance of P3, P1, comma distance of P6, P1. So from this we take the minimum, that is 0.22. Likewise, we have to update the distance matrix. After that, what is the minimum distance now? 0.15. That is P3, P6, P2, P5 is merged now. Likewise, initially P3, P6 and P2, P5, then you have to merge all those things. This is a dendrogram. Again, you have to update the distance matrix. Likewise, P1, this is the one cluster, this is the one cluster, this is another cluster. This is one cluster, this is one cluster, this is another cluster. Again, we have to find out the updated distance matrix. Now the minimum is 0.15. That means, so P2, P5 is 1. Again, P3, P6 is combined. Then that can come with which one? P4. This is this one. Likewise, the dendrogram is formed. This one. P3, P6, P2, P5. Then you have to one thing. Then you have to P4. Again, you have to calculate the distance. Update the distance matrix. Likewise, the final one is P2, P5, P3, P6, P4 to P1. Now, the first we have to merge 3, comma 6. Then 2, comma 5. Then you have to merge these two. Then we have to merge this one with 4. Then you have to merge with which one? 1. This is a single cluster. Okay, that is hierarchical clustering with single linkage. If you want using the hierarchical clustering with max link, just we have to maintain the max here, max of this distance. Okay, that is the only difference. But when we want to group the clusters, when we want to find out the closest pairs, we always take the minimum value from the distance matrix. Minimum value from the distance matrix. But when we are applying the distance, okay, different distance techniques or different linkage techniques. In min linkage, take the min of these two. In max link, take the max of these two. This value can update it into the which one? Distance matrix. That is one difference. Okay. This is summary of this lecture. First analysis, group objects based on similarity and has wide applications. Okay, and also various types of we may apply on various types of data. Maybe some right now some structured data, unstructured data. That is, we can also apply cluster techniques for document data also. Okay, and the cluster algorithm can be categorized into partitioning, hierarchical, density based, weight based, model based. We can also have a lot of research on the constraint based clustering also. Okay, so thank you.